Assalamualaikum and a very good day. I am Mohd Taqwa bin Mohd Azmy, a student from 4BEA section 1/2. Today I will be presenting for my project, which is Smart Bracelet for Child Tracking Purpose for subject Bachelor's degree project. As you may know, my supervisor is technologist Dr. Aliza Binti Amran. Let's start off with the introduction for my project. The main focus for my project is child security itself. Children security has always been my priority. As for my project, when the device detects an unsafe condition, the device itself will trigger and provide alarm for the guardian. The main purpose of my bracelet, my project, the bracelet itself, is to keep track of the kid while doing activities at an open area. For an example, we are doing an outdoor activities with our children. So the device itself will keep track on the child, whether they gone too far, they will provide an alarm, they will trigger an alarm, so we may alert on the child behavior. Next one, for the project objective. My project's objective is to design and build a smart bracelet for tracking purpose using a Node MCU ESP32 microcontroller, and to integrate an IoT system for tracking device. For my project, I'll be using Bluetooth connection system to provide location display and to provide an alarm for both parent and child device. This may apply for an IoT system for my project. And the last one, to verify the functionality of the developed prototype. I will later explain how my prototype works. Let's go. Next. There are several steps that have been taken for my research on this project, which are to specify several stages of detection range required for the project. Second one, to provide suitable alarm function for its required range, which is after the child reach at several meters or several specified range required by the device, it will trigger an alarm so that the parent may alert. Last one, to investigate and apply the SSI algorithm to determine minimum and maximum range of detected device. This I will explain later on the slides. These are the total costs for my project development. I am using the LED, vibrating motor, battery, and a development board, which is ESP32 itself. The total cost of my project is around 68 ringgit and 50 cents. Before this idea came up, I have provided another idea, which is using an Arduino Pro Mini as a microcontroller, and I found that Arduino microcontroller produce more steeper cost, which is more expensive for the project to be built. And I'm doing a comparison for both idea that I have implemented. So this is you can see on the slide here. For Arduino Pro Mini, we have cost around 80 ringgit 50 cents. So I've reduced the cost by changing the microcontroller itself using the Node MCU ESP32. So the total cost around 68 ringgit. So you can reduce price around 15 ringgit, sorry, which much cheaper to build this device. Now I am explaining about result and analysis for my project. For my project, I am using an RSSI algorithm to calculate the distance relationship applied for both device, which is the parent device and device worn by the child. By using the RSSI formula, the distance relationship will apply by using the formula given, which is D is equal to 10 power of bracket A minus RSSI bracket divided by 10 times N, where D is equal to undefined distance needed, N is a path loss index in required environment, and the last one, A, is the strength of signal received from a reference node, and RSSI itself is acquired from the device located. The value of the device which is located around device, with let's say the parent device detects the child device, so we can get the RSSI value from that. Okay, the RSSI signal obtained by using the RSSI algorithm that I explained before can be generated in a form of RSSI wave here, as shown as in the graph here. Okay, so as you may know, the graph here can be generated using an NRF scanner in mobile phone. Okay, you can see here the difference of each wave. Okay, for RSSI signal at 0.1 meter, which is the closest device from prototype. Okay, they said we have two devices, which is prototype and the child device. Okay, we put it at closest, which is at 0.1 meter, around 10 cm. Okay, you may get this kind of wave here, which is the number of value of RSSI is increasing. Okay, and I have tried to put at far distance, okay, at 0.8 meter, which is at around 80 cm, and I found that the RSSI signal is decreasing again, but back to 69, negative 69. Okay, and the last one I have tried to put at farthest that the device may detect, which is 1.5 meter. Okay, as you can see here, the RSSI signal is decreased again to negative 79 like before. Okay, at 0.8 meter you can see at 69, negative 69, and 1.5 will decrease up to negative 79. Okay, I will put it in simplified visual here. Okay, there are acceptable parameters for my project, which is the effective range of controller component that I use for my project. Okay, in safe condition, which is around 0.1 to 0.7 meter. Okay, the only alarm triggered on that condition is green LED. Okay, for the second one, on moderate condition, which is at 0.8, around 0.8 meter, vibration motor and yellow LED will be on, which is will be alert. The device itself will be alert on vibration motor and the yellow LED. Okay, when it comes to danger condition, which is on 1.5 meter or higher, it will trigger a buzzer sound, which is quite loud, and a red LED will also turn on, which represent that to show that the child device is on the danger condition, or maybe the fathers, the parents, which have to be aware of the child location. Okay, these are the circuit diagram that I did design. Okay, for your information, the circuit design will develop using a Proteus 9. Okay, as you can see here, I'm using the vibration motor, the buzzer, and LED, and this one is the development board I have used. The battery voltage rate is around 3.7 volt. Okay, these are the mechanical casing design that I have drawn for planning. Before I am planning to apply for my project. Okay, the reason to apply this design on my project, which is it is compact, so I have no need to use a larger space for my project, and it is user friendly, so you may equip and unequip easy for you to take it off and take it on your arm. Okay, and the last one, it is because it is easy mobility. You can wear it as a normal smartwatch that you have, or any watch that you have, so you can bring it around. As for your information, the battery itself will last long, around 2 to 3 hours, which is quite long for an outdoor activities that you can go with your child. Okay, for your information, my project have to done a casing replacement process, which is I cannot do the previous design here, mechanical casing design that I have drawn, because of the COVID-19 plague, which I cannot find a suitable printer, which is I have to 3D print out the design so that I can apply the casing on my project. Okay, now I will show you on how do my prototype works. Okay, I am providing you with an illustration which you can see and you may understand quite simple and quite clear. Okay, so you can see here the parent's phone, which you or any guardian may equip, will receive a BEEU signal from both devices, which is the parent device. Okay, the parent device is the prototype that I am making for my project, okay, which is worn by parents. And as for the child device, you may equip them with any kind of device, which is smart band or key tag. Okay, now I will explain briefly about poster presentation for my project. Okay, as you can see, most of the contents here was already explained earlier in this video, starting from introduction, objective, research methodology, and results and discussion. If you want to check further for my poster presentation, I have included the URL links provided in the description of my video. Thank you. So let's continue with the demonstration video we will provide it after this. Okay, let's continue with demonstration. For my project, I'll be doing two different types of situation, which is one for outdoor scan and second is indoor scan. Okay, let's start off with outdoor scan. I am doing this scan outside my house so that we have to know whether the defective or BEEU signal is quite good or not. Let's go. Okay, that is for outdoor scan, which is the effective of the signal is quite good, and I stand up in front of my device is around 1.5 meters away. Okay, let's continue with the indoor scan. As for indoor scan, I am doing with this inside my house. Okay, so let's go. Okay, quick question. Based on two different types of scan before is shown, which environment is more effective? As for my opinion, the indoor scan is more effective. As you can see in the video, it is in closed environment, which is the BEEU signal we can travel or receive or send much faster and more effectively, so that each device can receive the signal and can interpret the signal so that they will trigger the alarm much more faster and more effective. Okay, now I am going to show you on how the real situation of the demonstration works. Okay, let's go. Okay, as you can see here, after the alarm triggers and I didn't notice where the child is located around me, so I open up the BEEU app scanner and display the location of the device. Okay, let's look up in a clear picture. Okay, this is the photo that I screenshot from my phone apps, which you can see there are two dots here, which is red and blue. Okay, these two devices represents both child and parent device. Okay, as for my device, I name it as an HU, which is the prototype, the parent device, and the child device is named as PS. Okay, I think that is all from me. Thank you for listening. I hope you enjoy the video.